Question number 3. A particle P with mass 3m kilogram, particle Q with mass m at rest. On a rough horizontal surface, the distance between them is 1.4. An impulse of magnitude lambda Newton second is now applied on P on the direction of PQ. Okay. Immediately after the impulse is applied, the speed is 5. So we have here the U is 5. Find lambda in terms of m. So here, what we have here, we have the impulse. In the first part, impulse equals m v minus u. So first, the impulse is lambda, m, and v is 5 minus u, the starting here, where is this? U equals 0 at rest first, and after the impulse, the v equals 5. Okay? So 5 minus 0, which is equal, here 3m, particle P is 3m, so it's equal 15m. This is the value of lambda. B, immediately before P collides with Q, the speed of P is 2.5 meters per second. So here we have a different situation. We have here the speed or the velocity, the initial velocity will be 5 meters per second. And exactly before, immediately before collide, V here is 2.5 meters per second. So we have here deceleration, okay? Why? Because the opposite force here is mu r, the fraction, okay? And we need here to get the value of mu. So down is 3mg, the force, and up we have a reaction, and there is no forward forces. So we have u, v, and 1.4 the distance. To get here, we have the rule here, which is ma equal the opposite force negative mu r, and m here is 3m. Okay? So we need here to get the acceleration to get the value of mu. So let's write it down here again. Forces, we have the force which is ma. For particle P, it's a 3ma equal negative mu r. It's just the force backward here is mu r. Okay, the fraction. And we have another equation which is r equal 3mg. But in this equation, I can substitute, yes, 3ma equal negative 3mg multiply mu, and we can cancel 3 with 3m and 3m, so acceleration equal negative mu g. I need to get the value of mu. To get the value of mu, I need to get the acceleration first. So I need to work so that here we have the initial velocity u, and we have v, and we have the distance 1.4. So let's write it. U equal 5, v equal 2.5. The displacement is 1.4. We need to get the acceleration. So I'm going to use v squared equal u squared plus 2as. V is 2.5 squared equal 5 squared plus 2as. So the acceleration will be equal 2.5 squared minus 5 squared divided 2.8 negative 375 over 56. So I'm going to use it here. So mu will be equal the acceleration negative 375 over 56 divided g, which is 9.8. So we can divide by 9.8. Actually, this is negative mu. Okay, so cancel the negative. So it will be equal 0.683. 0.683. Part C, find the speed of P immediately after P collides with Q. The speed of Q is 2.1 meter per second. So we can write it here. We have the particle P and particle Q, okay? Now we have P with initial velocity, U is 2.5 immediately before, okay? Immediately before collide with Q. And the Q, UQ equals 0, it's at rest. And VQ, he gave it to me, the speed of Q is 2.1. And we need to get VP. This is 3M, this is M. Okay, so how to solve this? We have the rule M1 V1 plus M2 V2 equal M1 U1 plus M2 U2. Okay, impulse equal impulse. So here it will be 3M VP plus M multiply 2.1 equal 3M multiply 2.5 plus U here is 0, so this will be 0. So to get VP, we can first cancel M, and then 3 multiply 2.5 minus 2.1, then divide by 3, so it will be equal 1.8. Okay, and it will be positive because after hitting this way and it was at rest, so it will move this direction, so it will be positive